Welcome to iTTV for Form 4 Chemistry. The title of this lesson, Types of Reactions. Now, we've already had a look at some of the careers that you can get in chemistry. Before we actually start the main part of our chemistry, it is very important for you to understand and to recognize the types of reactions that occur in chemistry. Now, there are many reactions, but we'll condense these reactions into 5 main reactions that we are going to see quite commonly in our Form 4 and Form 5 chemistry. There are 5 main types of reactions: synthesis, decomposition, single replacement, double replacement, combustion. These are the 5 main types of reactions we have. So what we're going to do now is look at each one individually and try to give you an idea about how to spot reactions and the type of reactions that you are facing. Now, if you know the type of reaction that is occurring, it is much easier to understand what your products will be or what the point of a question is. Synthesis, reaction between element and element. So the first type of reaction that we are going to look at is called a synthesis. Now, a synthesis is the most simple or basic of all our reactions. Let's go up to the board and have a look at 1 or 2 simple, straightforward syntheses. Now, the most simple of all syntheses is a reaction, like we said, between an element and an element. What we'll do is we'll do a reaction between a metal and a non-metal. So if we take iron and react it with oxygen. Iron is an element, oxygen is an element. When you react these 2 elements together, so let's draw this in here. So let's say that this is an iron and this is the oxygen. When you react these 2 together, you're going to produce iron oxide. And the iron oxide compound should look like this: an iron and an oxygen combined together. Very straightforward. Iron plus oxygen gives you iron oxide. You can also do synthesis with 2 non-metals. Example, if you take carbon plus oxygen. If you react these 2 together, you're going to produce carbon dioxide. So your product here is carbon dioxide. So what would this reaction look like? Well, if you imagine that you had the element carbon and it was reacting with an oxygen molecule like this, and after the reaction you'd have carbon, 1 oxygen here, 1 oxygen here, and you'd have your carbon dioxide. So this is what we mean by synthesis. 2 elements, iron, oxygen, or carbon, oxygen, react with each other to produce a compound, a new substance with new chemical properties and physical properties, such as iron oxide or carbon dioxide. Single displacement, reaction between an element and a compound. A more reactive element will replace a less reactive element out of a compound. So this is the second type of common reaction that we have. In fact, it's one of the most important of all reactions, the single displacement reaction, where something that is more reactive will replace a like type ion that is less reactive out of its compound. Let's go up to the board and have a look at a few of the single displacements. Let's draw a line down here. So now we're looking at single displacement. Now, the first of the single displacement, let's try to put up a generic or a rough idea of what is happening. Whenever we have a single displacement, we're going to have an element, let's call the element X, that will react with a compound A, B, like so. Now, what is going to occur in this reaction is the element X is going to replace one of the elements in the compound. Now, metals will replace metals or the hydrogen ion, and non-metals will replace non-metals. So in this instance here, what's happening is X is going to replace A. A is going to be taken out. So our product is going to be X B plus A, like so. So let's have a clear look at what's occurring here. The element X is attacking the compound AB. The element X will displace or replace A. So our product becomes XB plus A. Now, for this reaction to occur, X must be more reactive than A. So make a point here. X is more reactive than A. Very important that you remember this, because if X is less reactive than A, then no reaction will take place. So this is what we call a single displacement, where one element reacts with a compound. So that's what you've got to keep your eye open for, an element and a compound. And the element will replace or displace another element in the compound because it is more reactive. Single displacement. These involve hydrogen compounds where the hydrogen ion is positive. Example, in acid. So now we're looking at the single displacement reaction, but specifically when hydrogen is involved. Now you're going to find that a lot of the things that we do in Form 4 and Form 5 chemistry involve compounds that contain hydrogen. For example, acid. So when we look at an acid, you got to understand that it contains the hydrogen and it also represents a compound that can be displaced, such as in a single displacement reaction. Let's move up to the board here and have a look. Okay, let's have a look at the displacement. This is a displacement with acid. Okay, so single displacement with acid. Once again, element reacts with the compound, so our element will be X. Acids are written out with the symbol HA. So the H in the front, that represents the hydrogen. So what's going to occur now is the element is going to attack and replace the hydrogen, which will produce for us X A plus hydrogen gas. So this is a reaction with acid, where X is replacing the hydrogen. Once again, what's important to understand is X must be more reactive than hydrogen. So let's make a note of that here. X more reactive than hydrogen. Okay? If X is not more reactive, you can't get a reaction. So very similar reactions, except instead of a compound, a salt, AB, we're using the acid, HA, and it's the hydrogen that's going to be attacked. Single displacement, reactions involving water. So with water, also we have to be aware that it undergoes what are called displacement reactions. Now, we're very used to regarding water as H2O, but really it is a bit easier to look at water as two parts, the H, the hydrogen part, and the OH, which we call hydroxide. So let's have a look at a displacement that involves water. So let's have a look at water now. Also with regards to a single displacement reaction. Now let's do it like we did it just now. With all single displacements, we have an element reacting with the compound. So let's keep the element the same, X, and we are reacting with the compound. In this case, the compound is water, H2O. Now, if you were told normally that X is going to do a displacement with water, the problem we have is we imagine water to be H2 and O. So what we imagine is going to happen is that the X is going to displace the hydrogen and join up with the oxygen, meaning we would get a compound something like this, XO plus hydrogen. In truth, this is completely wrong. This is not what is going to happen. What occurs is slightly different. You need to imagine or be aware that the water molecule is actually a hydrogen and what we call a hydroxide. So don't think of water as H2O. Think of it as H and OH. So which means when you do a displacement, the X is not going to replace all the hydrogen, but the X is going to replace one hydrogen and form a compound with OH. So what we do get is this. X displaces H and forms a compound with OH. So we get XOH. And the hydrogen that has been displaced is produced as your hydrogen gas. So this is a displacement that incorporates water. If you look at the three displacement reactions that we've had a look at. In the first one, X is displacing A from the compound AB. In the second one, involving acid, X is displacing the hydrogen out of the acid. All acids contain hydrogen, so therefore all acids can undergo a displacement reaction. And finally over here, X is replacing the H ion in water and forming a compound with the OH, the hydroxide, to form X hydroxide plus hydrogen gas. So please be aware of the displacement reaction. Always the key and the most important thing is the X must be more reactive than anything that it's going to replace. Double replacement. A compound reacts with another compound. The cations change places. Now, cations are basically our metal ions. And later on in chapters 3, 4, and 5, even a bit of chapter 6, we'll have a look at these cations in a bit more detail. But for now, just understand that a cation is a metal ion or a positive ion. Now, what's going to happen is when you put two compounds in together, the two metal ions or positive ions are going to change places, so we get two new products. Let's have a look at some simple double displacements. So what we're looking at now is a double displacement. Not a single, but a double. Oops. So we're looking at a double displacement. Let's try and put out a generic equation for this. Let's say we have A, B reacting with X, Y. Now, when AB reacts with XY, normally the cations, the positive ions, are written in the front. So these are the positive ions. What's going to occur is, like we said, they're going to change places. A is going to go to where X is, and X is going to go to where A is. Very straightforward and simple, which means that my new product is going to be X B plus A Y, like so. So let's have a clear look at what's occurred here. AB plus XY. A changes place with X, X changes place with A. What do you get? You get X going up with B, XB, and A now joining up with Y, AY. And this is called a double displacement reaction. We also tend to call it a double decomposition reaction or a double replacement reaction. All just many names for a simple reaction where the two positive ions are swapping places. Decomposition. A compound is broken down into new products. Now, the last of the reactions that we are looking at is called a decomposition reaction. Now, in a decomposition reaction, we are taking a compound and breaking it down. This you may recognize from your lower secondary when we did the limestone cycle, where when we took limestone and heated it, it broke down into calcium oxide and carbon dioxide. This is a very similar type of reaction to that, which is also a decomposition. Let's go up to the board and have a look at one or two decompositions. So let's draw a line up here, like so, and let's have a look at decomposition. Now, in a decomposition reaction, what we're doing is we take a compound and we are going to break it down into its smaller parts. Example, let's take AB. Let's take AB like so. Now, when we react AB or we heat AB up, so normally in a decomposition, we're going to heat it up, although some of them can actually decompose at room temperature because they are very, very unstable. So when we do this reaction, what tends to happen is this. The A and the B are going to split apart, and both of them are going to combine with oxygen. That's right, they're going to combine with oxygen. So imagine that up here we have a little bit of oxygen. Our products are going to be A joining up with oxygen to produce A oxide, and B also joining up with oxygen to produce B oxide. So this is what tends to happen in a decomposition reaction when we heat it. The two elements in the compound split and recombine with oxygen. We can also have a slightly more simple type of decomposition, some of which occur in our electrolysis. Now, if you remember your electrolysis from lower secondary, the electrolysis of water, when you electrolyzed water, H2O, it broke and produced hydrogen and oxygen. There was no combining with oxygen or anything like that. It just broke into its two elements. This would be the simplest type of decomposition. So let's have a look at that type of a decomposition. Over here, let's call it type 2. So in decomposition type 2, let's take the element or compound AB again. When you take AB and you zap it with some electricity, what's going to happen is AB is going to break and produce A plus B. So we're getting our original elements back. If you took aluminium oxide and you zapped it with electricity, you would get aluminium and oxygen gas. And this is very important because this is actually how we extract some of the more reactive metals in industry. So please remember your main reactions. We have 5 types of reactions, and if you can try to remember the keys to these reactions, they will help you in your chemistry. Remember, a synthesis is an element and an element. In the single displacement reactions, they are always an element reacting with a compound. In double displacement, we have a compound reacting with a compound, and in a decomposition, a compound is going to break down into several new products. If you can remember this, what will happen is when you're doing your chemistry and you see a reaction given to you and you notice that there is an element and a compound, well, immediately your brain is going to say to you, this is a single displacement. If you see a reaction that contains a compound and a compound, your brain is going to go double displacement. So this is how you're able to recognize the reactions that are occurring, and by knowing the reactions that are occurring, you're going to be able to predict the products. You're going to be able to predict what's going to happen. You're probably going to be able to predict the observations, color changes, gases produced, all of which a chemist must be able to do. That's all the time we have for this lesson. Thank you for watching iTTV.